Hello, my AB Calculus class. Here we are working on 2017, question number 5. It's an S of t, V of t, A of t, position, velocity, acceleration question. And it's got some difficult parts, or some parts where you can make some easy mistakes. Okay, so part A says, when is particle P moving to the left? And this is a great time to be, whoa, particle P. So if you read the question carefully, we have two particles that are moving along the x-axis. One of them is particle P, one of them is particle Q. And you've noticed I've lumped their information together. So the only thing we know about particle P is its position function is given by this equation. And we know two things about particle Q. This is the velocity equation for particle Q, and we know at time 0, this is the position of particle Q. Okay, with those two things in mind, let's answer for part P. So, when is particle P moving to the left? So let's talk about velocity really quickly. So when velocity is greater than 0, a particle is moving to the right. If it was moving up or down, it would be moving up. And when velocity is less than 0, it's moving to the left. And when velocity is equal to 0, we say the particle is at rest. So in this question, when they want to know when is the particle moving to the left, we want to know when is the velocity negative. Okay, and from time 0 to 8. All right, so we need to make a sign chart of velocity, and to make that sign chart of velocity, we're first going to take the derivative. So again, this is part A. So we're dealing with particle P, and we take the derivative. Okay, so the derivative will give me the velocity. And notice when I take the velocity, I'm being very careful to label it P, not to be confused over here with Q. All right, so this is the ln derivative. The derivative of ln of u has u on the bottom, so all of u on the bottom, and its chain on the top. The derivative of this bottom is 2t minus 2. Okay, that's it. That's the derivative. And now we need to make a sign chart. Before we can make a sign chart, let's go ahead and label our sign chart. First of all, we know it's going from time 0 to time 8, and I'm going to make sure to label it like this. That's VP. Okay. We need to know when is this equal to 0. Before we can find out when is it positive or negative, we need to find out when is it equal 0. And let's just start with the denominator. You might wonder, does this denominator factor? And the answer is no. Now think about this really quick. If you try to find numbers that worked, and you won't because it doesn't factor, you might think, I don't have a calculator on this question. How do I know it never hits 0? You could do the quadratic formula. However, look at this. It's t squared, it's a parabola facing up, and this is a plus 10. Now, if it's a plus 10, the graph can still go down a little bit, and we don't know how this graph looks, but it's up there at 10. The y-intercept is 10, and it's a parabola facing up. If this was a bigger number, we'd have some worries, but because this negative 2 here, it's actually not going to allow the graph to go that much further down. So, just so you know, this right here, the bottom, no matter what you plug in there, is always going to be positive. And that's a tricky part of the question. So if we want to know when will this equal 0, the first thing I do is multiply the bottom to the other side. It just gets destroyed. So it's really when is 2t minus 2 equal to 0. And if we add 2 and divide by 2, we get 1. So on here on the sign chart, we're going to put a 1. And then we're going to try a number on both sides. So I'm going to try a number. I'm going to plug in a half. When I go to plug in a half, so if I just put a half here, you'll see 2 times a half is 1, 1 minus 2 is a negative. And on the bottom, when I plug in a half, if I plug a half in here, I told you the bottom is no matter what always going to be positive. So we get a negative over a positive, which is a negative. And now we're going to pick a number between 1 and 8. Let's use 6, and when I put a 6 here, you can clearly see it's going to be a positive on the top. So positive on the top, the bottom's always positive, which is a positive. Okay, so now that we have these answers, we can say our answer to part A, it's moving to the left from, let's just say 0 to 1. So you can say from time 0 to 1, or you could say left from Now, do they ask us to justify? They do not ask us to justify, but they might on your AP exam. So how do we justify this? We'd say it's moving left from time this to time this because velocity is negative. If you're justifying, remember you just talk about your sign analysis chart. You label your sign analysis chart and you talk because velocity is negative, it's moving to the left. If they said when it is moving to the right, from time 1 to 8 because velocity is positive. All right, that's it for part A. I'm going to leave this part of the answer up here because we're going to need it later on. All right, part B says, when is, find all times t during which the two particles are moving the same direction. They will be moving the same direction when their velocities have the same signs. When both of their velocities are negative, they're both moving to the left. When both are positive, they're both moving to the right. So we need to have a sign chart for both of their velocities. So I already have this velocity for particle P. I'm now going to make a sign chart for particle Q, and that's going to help us answer this question. All right, well, good news. Particle Q, we're already off to a good start. They gave it to us. We didn't have to work for it. And this time we have something that does factor. So my first sign's a minus times a plus is a minus. Numbers that multiply to give me 15 are 3 and 5. And that gives you time equals 5 and time equals 3. I'm going to make this a little bit more obvious. I'll put the 3 here and the 5 here. There we go. And if I make a quick sign chart, if I plug numbers in, like if I plug a 2 in here, I'll get a negative and a negative. A negative times a negative is a positive. I'll get a negative here and a positive here. Okay, so if we quickly look, are they ever both moving left at the same time? They're never both negative at the same time, no. But are they ever moving right at the same time? Are they ever positive at the same time? So they're never negative at the same time, but are they positive at the same time? Well, yeah. They're both positive here from 1 to 3. So from 1 to 3. And again, you could say 1 to 3 like this, or you could say when time is between 1 and 3, like this. And they're both positive here from 5 to 8. And you could write it either way. Okay? So you'd say they're both, moving in the same direction. I don't feel like spelling. Oh my gosh. From this interval to these two intervals because they have the same signs. Okay, that's it. Part B is over. Make sure my answer is right. Yeah, okay. All right, let's move to part C. Part C says find the acceleration of particle Q at time 2. Is the speed of the particle increasing or decreasing at time 2? Explain the reason. All right. Well, we've got velocity of particle Q. They want the acceleration. So make sure you are dealing with the right piece. If there's two particles, make sure you know what particle you're dealing with. So it's particle Q. The derivative of velocity is acceleration. So the acceleration of particle Q is 2t minus 8. And if we plug in the acceleration at time 2, we get negative 4. All right, that's great. That's our first question. The second part is speed increasing or decreasing. Remember, to find out if speed is increasing or decreasing, you look at the signs of velocity and acceleration. When velocity and acceleration have the same signs, speed's increasing. When velocity and acceleration have different signs, the speed is decreasing. So if they have the same signs, speed's increasing. If they have different signs, speed's decreasing. So we only care about at time 2. So look at this. So the acceleration at time 2 is less than 0. And look at, we already made a sign chart over here. I could just go ahead and plug a 2 into the velocity and get an actual number, but I can use my sign chart and say my velocity at time 2, instead of getting an exact number, I can see it's positive. Okay? So I compare At time 2, acceleration is negative, velocity is positive, so I would say speed is decreasing. So speed is decreasing at time equals 2 because a of t, or a of 2, and v of t, or v of 2, have different signs. And I apologize for leaving that b up there the whole time. I'm getting back in the swing of things. That was part C. All right, so that's all done, and now we can go to part D. All right, part D says find the position of particle Q at the first time it changes directions. Okay, well, let's start here. Particle Q changes directions at time equals, and let's look, particle Q. Particle Q's velocity is positive, it's moving to the right, then it's moving to the left, then it's moving to the right. So this is the first time when it changes directions. So the first time it changes directions is at time equals 3. So now that we know at time equals 3 changes directions, they want the position of the particle. So they want the position. So they want, for particle Q, the position of the particle at time 3. And good news, they gave us some initial information. They told us the position of the particle, by the way, this is part D, at time 0. Now, if you're comparing these two, first of all, you got to remember the area underneath velocity gives the net change in position. So what we're going to want to do is we're going to do some integration here. But if you compare 0 and 3, 0 comes first. So this is the initial. That means this is the final. So 0 comes before 3. So it's initial position plus, and again, the area underneath velocity gives the net change in position. We want to know how much does position change from time 0 to 3. All right. The only thing I need to do here is make sure I'm using the correct velocity equation. So my velocity here is t squared minus 8t plus 15. All right. Question's not going to be that bad. We're almost done. So we have our initial position is 5 plus, and now we're going to take the antiderivative. Add 1 to the exponent, multiply by the reciprocal. Here we're going to add 1 to the exponent and then divide or multiply by the reciprocal. And the antiderivative of 15 is 15t. Now at this point we just plug in a 3 and a 0 and subtract. The good news is if you plug in a 0, everything goes away, so you really only have to plug in a 3. If you want to plug in the 0, fine, but you don't have to because it's all 0 this time. Whoops, got to plug in the top one first. I'm plugging in a 3. And then plug in a 0. If you want to plug in a 0 and put a 0, 0, 0, you can, or a giant 0, or even ignore it. It doesn't matter. And the important thing is this is the position of particle Q at time equals 3. No reason to simplify it. Again, initial position plus area underneath velocity gives the net change in position. So initial position plus net change in position gives the final position. And again, after you take the antiderivative, you plug in the top and the bottom and you subtract. All right, thank you so much. Bye.